Alright, this is exercise video number 26, and for my exercise today, I did abs, arms, and cardio. So I started out with just some Pilates and stretching, and then I did bicep curls, face pulls, lateral raises, front raises, and shoulder press. And then after that, I ran 1 mile outside with a pace of 8 minutes and 50 seconds per mile, and then just did a little bit of a stretch after that as well. And to relate this activity to what we're learning right now in exercise physiology, so whenever, for example, I was doing those bicep curls, I couldn't continue doing them after so many reps, and this is because of the buildup of hydrogen ions in that muscle. And so what happens whenever you exercise, we know that myosin and actin have to do those cross bridges, and every single time that myosin goes to grab actin, it has to recock and reset, and after every single recock and reset, whenever ATP is broken down into ADP and phosphate, you also get hydrogen ions, and so these hydrogen ions lower the pH in your muscle, ultimately not allowing them to forcibly contract the way that they should. And so these hydrogen ions have to leave the muscle somehow, and so what happens is you get obviously CO2 produced as well, and that is because whenever you are going through the Krebs cycle, whenever you're going from glycolysis to Krebs, you end with 2-pyruvate, and that pyruvate is turned into acetyl-CoA, and then you lose a carbon in the form of CO2, and so that CO2 has to go out to your blood, and so the CO2 leaves your tissues, goes into your blood, goes into a red blood cell, and then CO2 is dissolved in H2O, and then via the enzyme carbonic anhydrase, that turns into carbonic acid, and then carbonic acid is broken down into bicarbonate and hydrogen. And then that hydrogen goes to hemoglobin and forces oxygen off of hemoglobin, and then oxygen is able to enter your tissues, and then that bicarbonate goes out into your bloodstream, floats to your lungs eventually because it goes venules, and then veins, and then superior and inferior vena cava into your right atrium, and then your right ventricle, and then out into your pulmonary artery, and then pulmonary vein, back into the left ventricle, and so on. And so whenever you enter the lungs, that red blood cell with your carbon dioxide, that carbon dioxide has to go into your alveolus so that you can breathe it out. And so that bicarbonate that was floating around in your blood goes onto your red blood cell, and then that bicarbonate gets hydrogen off of hemoglobin, and then that forms carbonic acid, and then carbonic acid is broken down via carbonic anhydrase into CO2 and H2O, and then that is what you breathe out from your alveolus into your lungs, and then ultimately out of your mouth.